midsegments for the trapezoid, we also have a midsegment in a triangle. And the midsegment theorem says that the midsegment that joins two midpoints on a side of a triangle is parallel. So PQ is parallel to CB. And it's 1/2 the length of CB. So this is similar to the trapezoid, but instead of having to add the top and the bottom and take half, you just take half of the bottom. Sort of like with a, do you guys know the area for a trapezoid versus area of a triangle? If we take the area of a triangle, it's 1/2 base times height. If we take the area of a trapezoid, it's 1/2 of the two bases times the height. So, yeah, so the difference between finding the midsegment and finding the area is this height. If we take the height off, the midsegment of a triangle is midsegment is equal to 1/2 the base. We just don't multiply by height. And then the midsegment of a trapezoid is 1/2 of adding the two bases. So they're related to each other. So again, PQ will be parallel to CB, and it's 1/2 of the length of CB. Now every triangle has 3 midsegments. Okay, so if we have a triangle, okay, we'll have midpoint on each side. And of course, I'm guesstimating the midpoints. And each connection, again, not pretty, each connection is a midsegment. Okay, so if I labeled this triangle ABC, and the little triangle that gets created, we'll do RST. TS would be parallel to AB, and TS is 1/2 of the length of AB. No, they're the same slope. Parallel is just the same slope. So this slope would be the same as that slope. And then you have RS, that's this line, would be parallel to AC, and RS is going to be 1/2 of AC. And then RT, that's this line, is parallel to BC, and it's also 1/2 of BC. Little side note, this length here is 1/2 of BC. Well, the midpoint is at the halfway mark. So this length, and this length will all be the same. Does that make sense? And then the same will go here, these two, and this one, all three the same length. And finally, let's do purple. This length, and this length will all be the same. And the reason that occurs is because this is 1/2 of the whole thing, but the midpoint breaks this into 2 halves anyway. So you end up with 3 pieces that are the same length. Just kind of a nice little graphic to show all the lengths. In an equilateral triangle, all of them would all be the same length if you had equilaterals, so that's kind of nice too. All right. UV, that's this length right here, UV, is 11. So this whole length is 11, and I want to find XV. Well, this is a midpoint. So what do I know about this length here? It's half. So I take half of 11, which is 5.5. So XV is 5.5. D and E are the midpoints of ABC. We're going to try to find the following. I know AC is 12. So how much is DE? 6. AD is 5. So that's this little piece right here. And now I want to find the whole thing. Yeah. DE is 14. That's the short piece. What's AC? And now we'll throw some algebra in. So I'll redraw the triangle so we can label it nicely. I'll just put an E right here. This whole length is 4x minus 2. EC, this part right here, is 3x plus 1. What we know about this length is it's half of the whole thing. So I need to multiply this by 2 to get the whole length, right? So 2 times 3x plus 1 will equal 4x minus 2. Does that make sense so far? We'll distribute the 2. So 6x plus 2 is 4x minus 2. Subtract 4x from both sides. 2x plus 2 is equal to negative 2. Subtract 2. 2x is equal to negative 4. Divide by 2, and x will be negative 2. Now, my question tells me, though, to find BE. BE is the same length as EC. So BE would also be 3x plus 1. And since x is negative 2, we will plug that in. And we will get negative 6 plus 1, which will give me negative 5. And we'll just ignore the fact that a length can't be negative right now. Just plug it in. Yeah, the thing to recognize is that EC and BE are the same length. And so you can use EC to find BE. Well, because we had this theorem that said this outside angle was equal to the two remote interior angles added together, that turns into this new theorem, the exterior angle inequality theorem. So if I have the same triangle, oops, that doesn't work. If A is equal to B plus C, which we know for a fact is true, then A has to be greater than B and A has to be greater than C. Because if it's two things added together, it has to be bigger than each of those individually. Does that make sense? So if A out here is equal to B plus C, you take B and C and you put them together and you get A. A has to be bigger than just B by itself or just C by itself. Right? like if A was, let's say B is $5 and C is $6. If I put that together, I now have $11. That's what A would equal, would be the $11. So, and $11 is bigger than $5 or $6 by itself. So that's where this theorem comes from. Because A is B plus C, it has to be bigger than B and it has to be bigger than C by themselves. Does that make sense? Okay. Now we have another theorem. So if I have a triangle, okay, and one side is longer than the other side, so I know that this side is definitely shorter than this side. Do we all agree green is shorter than yellow? Okay, so let me label them. A, B, C. So AB is less than BC. Okay, we agree. Green is shorter than yellow. Well, if I look at the angles across, so the angle across from BC is angle A. Okay, so across is angle A. And the angle across from AB is angle C. Since AB is less than BC, angle C is less than angle A. And that's because the angle that opens wider creates the longer side. We could look at all three. AB is going to be shorter than BC, which is going to be shorter than AC. So across from AB, we have angle C is less than angle A, and that's going to be less than angle B. Maybe I should make my less thans a different color. I'll just highlight them. Less than, less than, less than, less than. Does that make sense? So as you go sides, smaller side is across from smallest angle. Largest side is across from the largest angle. Now we have the angles. So what we did here is we talked sides led to angles. This is the same thing, it just goes backwards. So here, what I have, let's say same triangle, ABC, and let's say angle A and angle C. Okay. We will say angle A is probably 38 degrees. And angle C is probably 30 degrees. We'll just say that. I'm just guessing. I didn't actually measure, obviously. Okay. Angle A is bigger than angle C. We all agree? So if we then go across to BC, or we take angle C and we go across to AB, since angle A is bigger than angle C, BC is going to be bigger than AB. So same exact concept, it's just on one we say bigger side is across from bigger angle, and on the other one we say bigger angle is across from bigger side. It just goes backwards. Okay, this one should make some sense. It says the sum of the lengths of any two sides of a triangle has to be bigger than the third side. So again, we'll have a triangle. And I'm going to label the sides this way, A, B, and C. Okay. A plus B has to be greater than C. A plus C has to be greater than B. And B plus C has to be greater than A. And let me show you physically. All right, but this is over two triangles. So if this side here is the same as this side, and this angle and this angle are not the same, but this side is the same as this side, hypothetically, I know I didn't draw them the same, but we'll pretend that they're the same. We'll call this angle A, and we'll call this angle B. Actually, let's not do that. We'll call this ABC, and this will be DEF. Okay. So AB is the same as DE, and AC is the same as DF, but angle A is smaller than angle D. That means that BC is going to be smaller than EF. Because this angle is smaller, that means it didn't open up as wide, so the third side is not going to be as wide or as long. So we'll do colors again. Oops, highlights not. So angle A is across from BC. Angle D is across from EF. So that means BC is going to be smaller than EF. Those aren't even really close at all. So basically this is the same thing but goes backwards. And what I'll tell you, you'll have AB is the same as DE. AC is the same as DF again. So we'll highlight those the same color. So AB is the same as DE. DF is the same as AC, but then we get a side, BC, is different than EF. Okay, so looking at this, I'm going to say that BC is smaller than EF. So going across, that tells me that angle A is smaller than angle D. So basically the same idea. It's just before we had one angle was bigger than the other, so that affected the sides. Now we have the side is bigger than the other, so that affects the angles. It's just going backwards like we did on the last theorems. Sides of a triangle. Well, 3 and 4 are the smallest, so we're going to check those. 3 plus 4 greater than 5, yes, we all agree? So yes, it can be the lengths of the sides of a triangle. The largest angle is going to be across from the largest side. So we have our 3 sides. Largest side, so it's going to be angle B. identify the shortest side. Well, first we need to find this missing angle so we know for sure. So I'm going to take 59 and 58 from 180. And that gives me 63. Okay. So I'm looking for the shortest side, which is going to be across from the smallest angle. So my shortest side is going to be MO. So far okay? Just always across, yeah. Which side is longer, AB or BC? Well, I want to know which one of these is longer. Here's a 51-degree angle. I'm missing a bunch of angles. But because these are both 32, that means these lengths are the same, which means this angle is the same as this angle, which means these are both 46. And because these are both 32, hold on a second. Oh, sorry, because these are both 46, I know what, I can find this missing angle, this whole thing. So I'm going to take 180 and I'm going to subtract the 46s. And that's going to give me 88. This whole thing is 88. This part of it's 51, so I take away the 51, and that tells me that this part's 37. 51 is across from AB. Do a different color. 51 is across from AB, and 37 is across from BC. So which one's longer, AB or BC? AB, because the 51 is bigger, so that makes AB larger. Okay, and then which angle is larger, angle 1 or angle 2? If we look at 16, it's across from angle 1. And 15 is across from angle 2. So which angle's bigger? Angle 1.